We've previously looked at and examined how systems undergo simple harmonic motion. Today we're going to be looking at the physics behind objects that travel in a circular path. And the physics behind objects that undergo simple harmonic motion and those that travel in a circular path are very similar. Before we go into this, we need to revisit the definitions of angular velocity. Now we know that omega is equal to 2 pi f or equal to 2 pi over the time period. But in circular motion, omega is also related to the linear velocity by this equation, where r is the radius of the circle. So what causes an object to go in a circular path? The velocity of the object is always going to be tangential to the circular path that the object is traveling in. So if this object was traveling in this circular path here, its linear velocity at this current moment will be in that direction. At position 2, it will be in this direction here, and at position 3 it will be in that direction there. Now for this object to travel in a circular path, the resultant force on the object should act radially, and what that means is it should act towards the center. So at all these points, the resultant force acting on the object will be looking like that. And using some of your knowledge of circles, what you should be able to notice is that the velocity and the resultant force are always perpendicular to each other. So when the force is perpendicular to the linear velocity, the object will travel in a circular path. Now this is true for any object traveling in a circular path. Now for an object traveling in a circular path, the resultant force on this object is going to be equal to mv squared over r. And this is known as the centripetal force. And we know that F is equal to ma. So the centripetal acceleration is equal to v squared over r. If you remember from earlier, we said that v is equal to omega r. So if we substitute that into this equation, the centripetal acceleration is also equal to omega r squared over r, which is therefore equal to omega squared r. So your centripetal force equation can also be written as m omega squared r, where omega is your angular velocity. Now this equation here should be given to you in your formula booklet. Now let's look at a scenario where we have a car going around the inside of a circular loop. Now I highly suggest you do not try this yourself. So let's examine the forces acting on the car at both of these points here. Well, we have obviously the weight of the car acting downwards, and we have the reaction force from the surface. And if this car were to go in this vertical loop, the centripetal force must be equal to the reaction force minus mg, and that would be equal to our mv squared over r, because we know that our centripetal force is the resultant force acting towards the center, and in this case it is going to be the magnitude of the reaction force minus the weight of the car. Now when the car is at the top of the loop, we're going to have its weight acting downwards, as well as also the reaction force acting downwards. So in this case, the centripetal force is equal to the reaction force plus the weight, and that's obviously equal to mv squared over r. Just a side note, these reaction forces aren't necessarily the same, so I'm going to call them r1 and r2 respectively. Now let's say I have a string attached to a ball and I'm holding it at this point here. Well, the forces acting on this ball are going to be the tension in the string plus its weight. So we know that the centripetal force must be acting towards the center of the circle. And if this ball was traveling in a horizontal circle, we need to resolve the forces acting on this ball in the horizontal component to work out the centripetal force. Well, the only horizontal force acting on this body is going to be T sine theta, and that is therefore equal to your centripetal force. Now the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.